Welcome to the de novo assembly of Ion PGM data using Floton Assembler with NextGENE software webinar. My name is Bruijn and I will be the presenter for this webinar. NextGENE software has a unique module for the Ion Torrent PGM sequencing system. It is a user-friendly software package with no scripting required and a project wizard that guides you through project setup. NextGENe for Ion PGM includes a Floton Assembler designed specifically for flow-based sequencing system to handle the homopolymer error profile. Additionally, the user interface allows for easy de novo assembly project setup and requires only 5 minutes to complete assembly of data from a 314 chip. Ion Torrent's personal genome machine works by calculating changes in pH to detect when a nucleotide is incorporated. One nucleotide at a time is flooded into the chip. Upon incorporation of a nucleotide, as in nature, a hydrogen ion is released. The resultant pH change is detected by a proprietary ion sensor. Due to this approach in sequencing, the Ion PGM has a unique error profile related to homopolymers rather than substitutions. The Floton Assembler was developed by SoftGenetics to deal with the homopolymer error profile. This method condenses the sequence into flow calls of individual bases and the number of bases in each flow as shown in the image below. In the example image, the flow size of 9 corresponds to a 17 base pair sequence. There are several advantages to using the Floton Assembler. 1. It converts the homopolymer errors into substitution errors. 2. By doing so, it corrects for most homopolymer errors. 3. It allows for faster computation time of de novo assembly. And 4. It runs easily on an inexpensive machine. In this example, all data files from the 314, 316, and 318 chip were ran on a laptop. To begin assembly, select Ion PGM under Instrument Type and de novo assembly under Application Type. Select Load Data. In the Load Data dialog box, select Load if the sample file is already in FASTA format. If it is still in SFF or FASTQ format, click on Format Conversion. In the Format Conversion dialog box, select Ion PGM and the appropriate file type from the drop-down menu. Load the sample file and select Output folder. At the bottom, you can make adjustment to the default filtering and trimming settings if desired. For more information on the filtering options, please see NextGENE Basic for Biologist webinar. Once you are satisfied with the options, click OK to begin format conversion. In the Project Wizard Assembly page, select Floton as the assembly method along with the small genome application type. The default setting generally works well for most datasets. One suggestion when using the Floton Assembler is to set the index length about 20 to 30% of read length in base pair for best results. For this particular dataset, the length is set to 24. The options highlighted in this area pertains to how the reads are combined and filtered. Error Tolerate specifies the percentage error threshold when combining sequences. Ignore option defines the ends of sequences. The cutoff option is the threshold to remove short assembled contacts, and remove low frequency threshold will remove sequences if there is insufficient coverage. There are additional options for Floton assembly that should be taken into account. The first is the condensation combine. This option will form contacts by matching reads with shared indexes. The next option is contact overlap merge, which will merge contacts by using the maximum overlap method. The output condensation Floton option will output all of the contacts with the length and the coverage in the title. This is the assembled sequence in FASTA format. If you want to view the assembly results in NextGENE Viewer, you can do so by selecting the option View Assembly Results in NextGENE Viewer. Click Finish when you are ready to begin assembly. After hitting Finish, you can run NextGENE right away or set up another run. In this example, I set up 2 additional projects, one for the 316 and one for the 318 E. coli DH10B dataset. The projects will run one right after another, and all output files will be saved in the designated folder. The final assembly is saved within the Assembled Sequences.fasta format in the output folder. This file contains all the assembled contacts from the project. If you have selected View Assembly Results in NextGENE Viewer, the viewer will automatically open up with the assembled results for reviewing purposes only. This table outlines the summary assembly results for the E. coli DH10B using a Floton assembler from NextGENE software. These 3 projects were ran on a laptop with an 8-core CPU and 8GB of RAM. For the 314, 316, and 318 chip, about 97.84, 98.44, and 92.83% of the raw data were used to assemble the contigs. The longest contig assembled is 328,018 base pair for the 318 chip. For quality control, the Assembled Sequences.fasta file from the 318 chip was aligned to the E. coli DH10B reference from NCBI using NextGENE software. For demonstration purposes, I am showing a coverage curve report for the alignment of the NextGENE Floton assembly results of the 318 chip to the E. coli DH10B GenBank reference from NCBI. The pink regions are areas that does not have any coverage. The gray region shows depth of coverage. About 93.2% of the reference genome was covered by at least one contig from the 318 assembly. The majority of the reference that does not have any coverage is attributed to the tandem duplication that is significant in the DH10B strain, which spans about 2.4% of the reference genome. To summarize, the Floton assembler was designed specifically for flow-based sequencing technologies. It converts the indel error profile to substitution errors and thus corrects for homopolymer errors. It offers a quick and easy way to assemble bacterial and smaller genomes with little to no change in the default settings. By using flow index, the Floton assembler ultimately lowers computational demands and analysis time, allowing a relatively inexpensive laptop to run all 3 datasets from the 314, 316, and 318 chip in about 3 hours' time. The biologist-friendly user interface allows for multiple assembly projects to be set up within minutes and run uninterrupted. This concludes SoftGenetics' webinar on the novo assembly of Ion PGM data using Floton assembler with NextGENE software. We would like to thank Life Technologies for making these datasets available on the Ion Community Torrent Development website. If you would like more information or want to try a free 30-day trial of NextGENE software, please visit www.softgenetics.com or send an email to info@softgenetics.com. You may also request for online training if you're interested in learning more about the software and its capabilities. Thank you for joining me in this webinar.